Welcome to Web Handling. My name is Dave Royce. I am super excited to start a new series on a topic that you've not heard from before on this YouTube channel. That topic is web handling equations that changed the world forever. In this introductory show, I will explain the whys and why nots of using equations. I will also share why I have, up until now, filled my books and occasional articles and conference papers with equations, but never discussed them in my schools or on this channel. Which then leads me to say why I've changed my mind, and in what way. I know your time is precious, so let's get started. I have a lifetime love-hate affair with mathematics and computer programs. On the love side, I taught myself some basic college physics and how to use the slide rule at around age 10. At that time, I loved science, but was quite indifferent to math. For those wanting the best performance on a slide rule, look for one that has an ivory inlay over bamboo wood with a glass cursor, such as this one. Part of that indifference was the clumsiness of doing math. While the slide rule was a big improvement over log tables, it could not add. This TI 2500 four-function calculator was introduced in 1973 for the equivalent of more than $500 in today's dollars. That indifference to math changed to hate, or at least major frustration in high school and later college, for both math and computer program. What saved me was my first computer in 1982, which I still have and use in this office, which was a Commodore 64. The basic language that it came with was much more approachable than bringing a stack of computer punch cards to a desk and then waiting till the next morning to find out that you had a syntax error in one of the 200 cards in the deck. A couple years later, Microsoft introduced QuickBasic, which was a most gorgeous language for the layman. The only major criticisms were the language was sloppy and interpreted rather than compiled. Soon there were basic compilers that allowed the program to run quite quickly, although sloppiness was never corrected. In any case, that approachable language allowed me to quite simply write winding models that became the core of my PhD thesis work, as well as part of the 2 winding books that I've written. Also, you will find hundreds of equations in about half of my books. However, what you should have noticed is that I very, very seldom ever use equations in teaching, presenting, and troubleshooting. I hope the following explanations will show you why. Computer chips enabled modern science and engineering. However, with regard to math, they come in 2 flavors. The first is equation solvers, which takes a given equation and given inputs to do a short series of calculations for you. Arguably, the first scientific calculator was this Bomar brain, introduced 1973. I was the first person in my college to have such a device. Everyone else was using slide rules. This changed almost overnight. One of the earliest programmable calculators was this HP 41C, which was the engineer's go-to for almost a decade. This Casio 780p was introduced a few years later, but it never took off because personal computers were easier to use. Yesterday, we had devices such as this TI-83 graphing calculator. Well, you would probably use an app on your phone nowadays. More capable equation solvers were computer languages, Microsoft Excel, MATLAB, and many, many others. However, all of these devices used a fixed equation which you entered in, and you also put in variables. To manipulate equations is a far different thing. Until the late 1980s, you had no choice but to do the manipulation by hand. Now, that changed with the introduction of the gorgeous Mathematica and the ugly Symbolics program, both of which I used for my PhD thesis work. However, most equations that are longer than about half a line are most likely hidden. By that, I mean that you are using a program that you can't see the equations within or really know how they are solved. Common examples include finite element programs such as ANSYS and later Abacus, both of which I used and mostly loved. Web handling specific programs include winding models and the Abbott apps. Yes, there are documentation of sorts for the underlying equations, but the user will seldom ever look them up. So, if you have more than a couple of my 10 books, you will note right away that most are chock full of equations that would be useful for machine designers, super serious troubleshooters, and finally, the very few researchers left in web handling. You will also have noticed equations in most of my iWeb papers hosted by the now defunct Web Handling Research Center where I received my PhD. What you will not see, with very few exceptions, was equations used in my school and, up until now, on my YouTube channel. The reason is simple. The more I toned down the tech, the more the audience liked it. So what changed? Well, it was an inspiration from Stephen Lang, a long-time P&G web handling expert and now a consultant, who presented what I thought was the most understandable treatment of some simple equations. This is actually much harder to do well than you would think. In any case, I decided that perhaps I could break apart some simple equations to show you what they tell us and how you can use them right now in your web handling work. And even if you don't use the calculations, what they will tell you. These are among a half dozen applications that you can use right now to do design and troubleshooting because they are super simple. These are what we will be covering in the next few weeks. Yes, we have Abbott apps that also do the calculations for us. However, the equations can teach us more quickly what is important than what does an app where you need to do a number of trial and error exercise to get a feel for the underlying connections. What we will not cover, because most are detailed elsewhere on this channel, are the Abbott apps. If you email me, I will send you a searchable index of all of my YouTubes and much, much more. Unfortunately, many winding models are far too complex for anyone but PhDs. Even someone like myself with a PhD in a winding area has great difficulty understanding models in another area and would never use them personally because I don't have the necessary subject matter background. At this point, you have probably wondered, what's in it for me, since I got a C in calculus or even high school algebra? The answer is that an expert teacher can bridge the gap between the PhD and the operator. We do that by using words and schematics instead of equations. The words are the list of options allowed by or suggested by physics. Things that are not on the list are secondary at best. That is how my award-winning and trademarked Web 101 training that has been taken by 5,000 people is different than almost all other teachers and almost all other teaching. Yes, I do mention equations, but only indirectly, via footnotes and references, not as main content. Since we don't get bogged down explaining equations, we can cover a lot more subject material. Better yet, since we don't use equations in our teaching, nearly everyone can follow nearly every topic area. Thus, Web 101 is for everyone from the operator to the PhD. Yet, there's a tendency to distrust things that you don't understand well, and equations are no different. So, when and how can you trust them? If we take simple examples like Newton's law and Einstein's theory of relativity, we have ample evidence from 100 years of testing by thousands and thousands of scientists that these equations work to tell us how the world works. In web handling, small equations can be similarly but provisionally trusted, provided that you have subject matter expert guide. The quickest way to do that is to go to school or read books. When you get to the rarefied world of models, you are pretty much limited unless you have a PhD and lots of time and lots of money to work on a small problem. The increasing narrowness of that R&D audience is why I tapered off of research more than 3 decades ago. I hope you've enjoyed this overview of the maths of web handling. Stay tuned for next week's show, where we will take a deep dive into the century-old band brake equation and what it tells you about roller traction, tension control, drives, and much more. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful, please like and share and subscribe. See you next time.